Hi guys, can you hear me? Just write down a yes in the chat if you can hear me. Okay. Okay, we'll start with the PCD in just 2 minutes. Okay, is my screen visible to you all? Voice. Hello, I think is my voice fine now? Okay, so I think we can start with the PCD now. So, hi everyone, this is Abhinav Kumar and welcome to the post-contest discussion of the Codeforces round 1022. Before starting with the discussion, let me just give you a short brief about the newly introduced second version of the CP31 sheet, which covers problems from a rating range of 800 up till 1900. There are 31 hand-picked problems from each of the rating. And in the new version of the sheet, you can even connect your Codeforces handle to the sheet, and all your progress from your Codeforces account would be linked to the sheet. Along with that, there is a leaderboard section through which you can compete with your friends on who solves more problems. Along with that, there's a dedicated discussion section for each problem. So do check it out and enjoy solving the problems. So now let's begin with the PCB. So let's discuss the first problem, which is the problem A, permutation warm-up. Uh, for a permutation P of length n, we define the function ft as the summation of pi minus I mod. You are given a number n. You need to compute how many distinct values the function ft can take while considering all possible permutation of the numbers from 1 to n. So basically, if you take any random permutation p, then the value of the function for that particular permutation is defined like this: pi minus I, the value at the ith index, a difference with the I, whatever is the absolute difference between pi and I, just sum that up for every I, and that summation is called FP. Now, what you need to find is how many distinct values of FP exist. So, if you consider all possible permutations of length n, then how many distinct values the function FP would have, that we need to compute. So, for example, if you take the first test case, okay, let's look at it here. For example, let's say if you take n equal to 3, what would be my answer? For n equal to 3, what all permutations can we have? We can have 1, 2, 3. This is one permutation. We can have 1, 3, 2. This is one of the permutation. Okay, like that we can have 2, 1, 3. Okay, or 2, 3, 1. So factorial 3 number permutation, that is 6 permutations we would have. Okay, so 3, 1, 2, and 3, 2, 1. Okay, these would be the 6 permutations we can have for n equal to 3. Now, let's compute the value of Fp for each permutation, which is defined as summation of Pi minus I mod for each I. So, here if you do it, take the index 1, 2, 3, then difference between 1 minus 1 is 0, 2 minus 2 is 0, 3 minus 3 is 0. So, for this Fp would be 0. For this, if you compute, here we would have 1, 2, 3. So 1 minus 1 would be 0, but 3 minus 2, this would be 1, and 3 minus 2, this would be 1. So here we would have Fp equal to 2. For this value, again, if we have 1, 2, 3, here we would have a difference of 1, 1, and 0. So Fp would be 2 here. Likewise, you can, let's compute only. So 1, 2, and a difference of 2. So here Fp would be 4, difference of 1, 1, and 2. Here, if you see, then here Fp would be 1, 2, 3. So difference of 2, 1, and 1, again 4. And here, if you compute, your Fp would be a difference of 2, 1, and 2. 2, 0, and 2. So a difference of 4. So overall, if you look, how many distinct values of Fp did we get? We got 0, 2, and 4. These are the 3 distinct values of Fp that we can get. So there are 3 distinct values. Our answer would be 3. So you can see for this n equal to 3, our answer was 3. Okay. So this is the problem. I hope the problem is clear to you. Now, how do we solve this problem? So just by analyzing the test case, let's see, some of the test case are analyzed below only. So for n equal to 2, you got the values of FPS 0 and 2. For n equal to 3, you got the values of FPS 0, 2, and 4. If you analyze for n equal to 8, you will get some values. Don't go very above. Let's analyze for n equal to 4. So here, always you can get a 0 by taking, you can always get a 0 by taking this permutation 1, 2, 3, 4 up to n. If you take in the sorted order, Fp would be 0. And what would be the maximum value that you can get? The maximum value would be when you take it in the reverse order. Okay, like, do you agree with it? When we take it in the reverse order, this difference would be 3, this difference would be 1, this difference 1, this difference 3. So we are maximizing the differences at first index. If we take the largest value, then if you go on decreasing it, that way, like, I is increasing like this, and if pi you take like this, then this difference would be maximum, then this, then this. So this way, if you take the permutation in reverse order, you would always get the maximum value that you can get. You cannot get more than this. So this one thing is Hello, am I audible and my screen is visible? I'm sorry, I got disconnected. I'm really sorry. Okay, just tell me where I till where I was discussing. Okay, I think here we were. Okay, we were here. Uh, okay, I think we had discussed how we are calculating f of p. Okay, and now we were discussing the logic of the problem, that how do you solve the problem. So from these values you can see, like for n equal to 3 we had calculated the values of fp, and we got these three unique values 0, 2 and 4. So there were three unique values for n is equal to 3. Now for n equal to 4, if you analyze, the minimum value would be, if you take it in the sorted order, you would get 0. Now if you take it in the reverse order, this way we would always get the maximum value. Okay, that's the first thing. If you take it in the reverse order, then we are just maximizing, like I is increasing like this from 1 up till n, and pi is decreasing like this from n up till 1. So here the difference is n minus 1, next difference would be n minus 3, this would be 0, and then again increasing. So we can maximize the differences by taking this permutation, the reverse permutation. So 8 would be the maximum value that we can get for n equal to 4. Now the thing here is, just by looking at the examples and all, you can understand that what are we getting. For n equal to 3 you got uh, for n equal to 3 you got 0, 2, 4. For n equal to 2, what did we get? For n equal to 2 you got 0 and 2. Okay, 2 was the maximum you can get, and you got 0. So 0, 2 here, 0, 2, 4. For n equal to 4, what you would get, just by analyzing you would understand that you are going to get this. These would be the unique values that you would get. Why? Because 8 is the maximum value, 0 is the minimum that you can make, and you can make all even values from the minimum up till the maximum value of 8. Now what is the proof for that? We'll discuss a small proof for that, but just by analyzing the test case and all, you can intuitively get it that this would be my answer. So my final answer would be, just calculate the maximum value, and then your answer would be number of even values from 0 to that maximum value. So here it would be, if it is 8, then it would be 8 by 2, 4 even values, these 4, and you add a 0, then so a plus 1 is 5 even values. So whatever the sum is, the maximum sum is, your answer is s by 2 plus 1. This would be your answer. Okay, now let's give you a small proof why all the numbers from 0 up till the maximum values, all the even numbers from 0 up till maximum value would exist, and none of the odd numbers would exist. So if you say for n equal to 4 only, by taking the array in this order, you can always make the maximum value, which is 8. Now how do you make 6? You want to do a minus 2. So if I note down the differences, here the first difference would be 3, next difference would be 1, next difference would be 1, next difference would be 3. So this sum is actually 8. Okay, now how do we edit these values so that you can do a minus 2? If you swap any two numbers, your sum is going to reduce, because this is the maximum you can get. Let's say you swap these two numbers, you would get a 2 here, 3 here. So these two differences would get reduced to 0. So if these two differences get reduced to 0, your overall sum would get reduced by 2, and it would become 6. Okay, so if you swap these two values, your sum would become 6. Now so you are doing a minus 1 and minus 1, a minus 2 in total. Let's say if you swap these two values, the value at index 3 and index 1, then at index 3 you would get a 4, here you would get a 2. So this difference would become 1. Instead of 3, this difference would become 1, and instead of 1, if you make 4 here, this difference would remain 1. So here also you would get a minus 2. Okay, when this becomes 1. So that way also you can make 6. How can you get a -4 is, let's say you swap these two values. You get a 1 here, you get a 4 here. So then you get a -3 and -3, you will get a -6. Okay, and you can even get a -4 here. Let's say, like, you can try different combinations. You will get -2, -4, -6, all the values. So like this way, you intuitively I can say that you will get all the even values from 8 up till 0. Okay, and why you don't get an odd values is also quite clear, because you are taking the summation of pi minus I. So if you open this mod value, if pi would be greater, it would be pi minus I, and if I would be greater, it would be I minus pi. Overall, if you look at any permutation, how many times this would be case when pi is greater than I? This would be the case when pi is less than I. Okay, so the number of times when pi is greater than I and the number of times when pi is less than I, these two would be equal. Okay, the number of occurrences of cell, if you analyze for all the I. Okay, then basically you can say, if you take the summation of this pi, then all the values from 1 to n is going to come. If you take the summation of this I, then all the values from 1 to n is going to come. So basically your final sum is from 1 to n, and then again from 1 to n. Then these signs would be either plus or minus. Okay, so I can write a plus minus everywhere. So half of the signs would be plus, half of the signs would be minus. And same, so if your final value has to be even, then the number of odd values has to be, whether it is plus or sign minus, odd values change the parity, even values don't change the parity. So basically this sign doesn't matter. For your final parity, the number of odd values, your final parity would be number of odd values, and the number of odd values are going to be whatever you have here, that many you would have here. So the number of odd values is going to be even, so your final parity is going to be even. So like this is a proof of why your final sum is going to be even, because your final sum is 1 to n. In pi you would get all the values from 1 to n, in I you would get all the values from 1 to n. Now they would have signs of plus or minus based on how the mod is going to get open. But if you just want to calculate the parity, then for parity the sign doesn't matter. If you either do +1 or -1, in both the cases your parity would change. So the parity is number of odd values. If that is even, that means parity is 0. If the number of odd values is odd, that means parity would be 0. Now here the number of odd values would always be even, because every value is coming 2 times. So I hope this proof is also clear, and why I'm writing like this is clear. So what would be my final answer? Now to calculate my final answer, I would first calculate the maximum sum. That would be, for any n, you take the reverse sequence n, n minus 1, n minus 2, like this. So here it would be 1, 2, 3, like this. So this difference would be n minus 1. This difference would be n minus 3. So your differences would be n minus 1 plus n minus 3 plus n minus 5, up till you would either go on to 0 or 1, whatever, and then same thing would get repeated. So let's say you go to 0, then it would be 2, 4, 6, like this. If you go to 1, it would be 3, 5, 7, like this, up till the maximum value again. So it's actually 2 times this value. So your sum is actually 2 times this value, s is this, and your final answer is, if you take all the even values from 0 up till s, so there would be 2, 4, 6, let's say s is 8. So 4 values, s by 2 would be the number of positive even values, and plus you add 0. So one more for that. So s by 2 plus 1 would be the number of unique values from 0 up till s, number of unique even values from 0 up till s. So your final answer would be s by 2, where s would be the sum of this AP. What is the sum of this AP? So you can take the sum of an AP, or if I look at the constraints once, then I think n is very small. So you can run a loop to calculate the sum, or if you want to calculate in O of 1, then you can take the sum of this AP. So sum of the AP would be, number of terms here is, number of terms would be n by 2. flow division. So let's say this is x. So number of terms by 2 into first term plus last term. So first term is n minus 1 and the last, so 2 times the first term. Okay, I'm just writing the formula for AP, although the formula is not required here. N is given only 500. You can run a loop and calculate. Still, if you want to do this problem in O of 1, it would be 2 times A plus your common difference is minus 2 into common difference into the number of terms minus 1. So x by 2 minus 1. Okay, so this would be the formula and 2 times that. Okay, so these two would get cut. So if you look at the final solution, x is n by 2 and my sum is x into, I've written that formula, x into 2 into n minus 1, 2 into n minus 1, 2 into a minus 2 is my common difference and d n minus 1, so x minus 1. So I calculated the sum of the AP and my final answer is sum by 2 plus 1. That's my final answer. So this way I've just calculated the answer in order of 1. Okay, so all are just formulas. So in order of 1, I've calculated my answer. My space complexity is also order of 1. I've used just normal variables. Okay, so I hope the problem is clear to you. You can even run a loop and calculate this sum. It would be order of n only. For the given constraints, still it would be accepted. Okay, I hope the first problem is clear. We can move on to the next problem. This is the code. Okay, people have written other ways also, so like you can derive formulas from that, and yeah, maybe those formulas are also correct. So let's move on to problem B, which is SUMdamental decomposition. On a recent birthday, your best friend Morris gave you a pair of numbers n and x and asked you to construct an array of positive numbers a of length n such that the XOR from a1 up till an is x. Your task seemed too simple to you, and therefore you decided to give Morris a return gift by constructing an array among all such arrays that has the smallest sum of its elements. You immediately thought of a suitable array. Okay, basically you want to find, you are given as an input two integers n and x. Okay, you need to construct such an array of size n so that the XOR of all those n numbers is x. Okay, and the array should be of positive numbers. So you have to pick up n positive numbers which XORs up to x, and you have to minimize the sum of the array. So the sum of these n numbers is what you need to minimize. Okay, says that the smallest sum of its element. You need to answer only the sum of the elements, the minimum sum of elements that you can get, so that the XOR of the n numbers is x. That's what the problem asks you. And you can look at the constraints. N is 1 in 9, x is 1 in n. So you actually cannot construct that whole array of size n. That would be order of n. You need to find some way to solve this problem in less than order of n time. Okay, in some order of 1, order of log n, like this. Okay, so how do you solve the problem? Okay, let's look at the one of the test case to understand more clearly what do you have to do. Okay, so here n is 2, x is 1. What does that mean? That means you have to form an array of size 2. So a1, a2, this would be an array of size 2, so that the XOR of this whole array, so a1 XOR a2, this is equal to x, and we need to, the sum of the array would be a1 plus a2. So you need to select such a1, a2 so that this sum is minimum. And what is the minimum sum that you can get is what you need to find. Okay, so for this particular problem, when my x was 1 and n was 2, then the array we can take with minimum sum is, finally your XOR of the two elements should be 1. So maybe you can take, all the numbers should be positive numbers. So maybe you can take 2 XOR 3, that would XOR up to 1, and 2 plus 3 would be 5. So in this particular way, you can do it, you can have a sum of 5. Can you do it in less than 5 with a sum less than 5? probably you can take. Yeah, I think 5 would be minimum for this test case. Okay, 5 is only the minimum for this test case. So here, whatever any two elements you take which XORs to 1, the minimum sum of those elements is 5. So 2 and 3 is the most suitable. There may be other ways. Let's say you take 6 XOR 7. Okay, 6 is 1 0 1 0, 7 is 1 1 1. 1 2 4. 6 is 110, 6 is 110, 7 is. If you take the XOR of these two values, it would result to 1. But 6 plus 7 would be 13. So, which 2 and 3 you can make a sum of 5, which is lesser. So, 5 is the minimum sum you can get. Okay. If you look one more test case, let's say 3 and 6. So, n is equal to 3, n is equal to 3, x is equal to 6. You need to pick up 3 elements which XORs to 6. Okay. One of the way is, so what is 6? Let's write this. So always think about the problem when you have bitwise XOR and all. Think about the problem in binary. Okay. Now let's look at this x in binary. So you want to make 6. You want to make this number. Now you need to pick up 3 values, the XOR of which is this. Now when do you ensure that the XOR of some n numbers is this? First is, we can analyze for each of the indexes or each of the binary digits. So the first binary digit is 0. That means in all the numbers, if you take the first binary digit of all the numbers at this position, how many ones do we have? That should be even. If we have even number of ones, then their XOR would become 0. Same way, if you have a final resultant of 1, then at these positions, whatever numbers you take, their XOR should be 1. So the number of ones in these positions should be odd. So one of possible way is if you take 0 0 0, if you take 1 0 0, let's say 0 1 0. Okay, and let's say you make it 1 and 0 0 1. Okay, so this is one possible way. Here this XOR would be 1, this XOR would be 1, this XOR would be 0, and these are all zeros. Okay, so if you take these three numbers, their XOR would be x. Now what is the sum of these three numbers? This number is actually 0 to 4, this number is 3, this number is 1. So 4 plus 3 plus 1 would be 8. Okay, so this was one possible way to make an array whose XOR is 6 and this sum is 8. There can be other possible ways also. Let's say here you make a 1 and here also you add a 1. Okay, still the XOR would remain 6 only, but this number would become 6, this number would remain 3, this number would become 3. So their sum would now be 12, which is greater. So 8 was the lowest that we can get. For this test case, you can see the answer was 8. Okay, and if it is not possible, then you would return -1. Let's say for 1 and 0. Okay, so for n equal to 1, x equal to 0, you have to make the final XOR to be 0, and you have only one number. So whatever number you take, if that has to be a positive number greater than 0, the XOR of a1 is a1 only, and the sum would also be a1 only. So whatever number you take, that number cannot be 0. So you cannot make a XOR of 0. That's why for this case, you would return a -1. Okay, I hope this -1 case is also clear. So I hope the problem is clear now. How do we solve this? So this intuition gave me like a particular way to solve the problem. So whatever x you need to have, okay, so you need to create an x. Okay, just analyze that x in binary form. Okay, so let's say here we had this. Okay, something like this. Some x we have, some random x. We have converted that in binary. Now, whatever are the positions where the bit is set. Now you need to have n values. Okay, you need to have n values with XORs up to this x. Okay, n positive values. So first of all, what is the like if n is, let's say, 1. If n is 1, then we would just take this number only, because you have to have these bits set. So at least in like for this position, if you see in at least one of the values, this bit should be set. In at least one of the values, this bit should be set. In at least one of the values, this bit should be set. So the minimum sum that we can get is x. Okay, it would never happen that you get a sum of less than x, which XORs up to x, because whenever you do a XOR of any two numbers, then the sum of the numbers is always greater than XOR. I hope you know this property. The XOR of any two numbers is always less than or equal to the sum of the two numbers. So it would never happen that XOR of all numbers is more and their sum becomes less than x. So the minimum you can reduce your sum to is x. Okay. Now let's see, can we have a sum of x using n numbers? So we have 1, 2, 3, 4, 5 set bits in this number. So if you have n less than equal to 5, so for n equal to 1, just take this number only. Your job is done. For n equal to 2, maybe one number you can set all of these bits, and in another number you can set this particular bit. Okay, so some of the bits are set in one number, other bits are set in another number. So with n equal to 2, you can do it like this. If n is 3, then in this also let's keep it 0. Here we would set it in the third number. For n equal to 5, we would have 5 separate numbers. In the first number, only this bit would be set. In the second number, only this bit would be set. In the third number, only this bit would be set. So until n is less than equal to 5, my answer would be x only. Okay, we can always keep our answer the minimum, which is x. Now what if n is greater than 5? Okay, or n is greater than the number of set bits in x. Okay, so let's say n is 6 for that, or n is 7. Let's say n is 7. So 5 of the numbers would be utilized in setting these 5 bits. Now you still have to take 2 more numbers. Okay, so from A1 up till A5, you set them as, in A1 you set, let's say, set this bit. In A2 you set this bit. Same way in A5 you would set this bit. All the remaining bits would be 0. What about A6, A7? Now these values also have to be a positive number. You cannot take 0 here. You cannot make A6 and A7 0, because you have to take positive number in all the values of the array. So at least one of the bits would be set here. So whichever bit is set here, the XOR of these numbers was x. With this bit, it would change your XOR. So for A7, set the same bit so that these A6 and A7 XORs up to 0. So your condition would be satisfied. So which bit would you choose to minimize the sum? It would be the first bit. Value would be 1. Here also value would be 1. So if you take this second bit, if you take 1 0 1 0, then it would be 2 plus 2. So why do you have to increase the sum? Just take the lowest that we can take, that is 1 and 1. So this way you would add a plus 2 to your answer. So your final answer would be x plus 2. Okay, so basically what you need to do is, whenever you have a n, first calculate the number of set bits in x. Okay, so if n is less than equal to number of set bits, answer is x only. If n is greater than the number of set bits, then calculate what is n minus number of set bits. Okay, how many numbers are remaining? That many times add a 1. Now what if n was 8 here? So the number of remaining elements were 3. So for this case, when number of remaining elements are odd, if you take another one, their XOR would be 1. So this would again disbalance our final XOR, which won't be equal to x. So I think before this, these cases are clear. So first of all, with x, you calculate the number of set bits in x. Okay, let's say SB is number of set bits in x. Okay, then you check if n is less than equal to number of set bits, your answer is x. If n is greater than number of set bits, for this case, if n minus number of set bits, okay, n minus number of set bits are the number of elements remaining. There you would add a plus 1 plus 1 plus 1. So if this is even, then no issues. Your answer would be x plus n minus sb, the number of extra elements that you add. Now, what about the else case? This you need to solve. I hope till here it is clear. Okay, this I think I can write as else. Okay, so if n is less than equal to number of set bits, answer is x. Otherwise, if the difference between n and number of set bits is even, answer would be x plus the difference. Now, what if this is odd? How do we solve the problem now? So if this was odd, let's say for there were 3 elements. So what we can do is, now you cannot have 3 ones. So you can have 2 ones, but this third element also have to have something. So what you can do is, you can have 4 ones. So what you are doing, you are using 5 elements to make x. Instead of using 5 elements, you can even make x using 4 elements. Okay, in this only, let's say you set both the bits. In one of the elements, you set both the bits. Then instead of using all the 5 elements, if you make x using only 4 elements, then you would have an even number of elements remaining. So you can have a 1 here, and even number of ones would resort to 0. So this way, you were able to make this. So the first 4 values would sum up to x, and then you have a 4 ones. So your final answer would be x plus 4 here. So for the odd case, if this value was odd, then your answer would be incremented by 1 more plus 1. Instead of having x plus 3, your answer is x plus 4. Okay. So you were able to, instead of using 5 elements to make x, you used only 4 elements to make x, so that remaining elements become even. So in the x else case, you can write your answer as x plus n minus set bits plus 1. Okay, so one small edge case is here. What if the number of set bits is, okay, what if the number of set bits is less than equal to 1? Okay, here when the number of set bits is at least 2, then you can combine two of the arrays into one to increase the number of elements by 1, so that your basically remaining elements become odd. But if the number of set bits is either 0 or 1, then what we do? Okay, so here again we would have, it won't be direct, but again you would have 2 cases. So if the number of set bits is greater than equal to 2, then this would be the answer. Otherwise, again we would have an else case where your difference is odd and number of set bits is less than equal to 1. So just handle this small edge case separately. What do we do here to handle this small edge case? Let's analyze for number of set bits 0 and number of set bits 1 separately. When is number of set bits 0? That means x is 0. This is the only case when number of set bits is 0. So what would be my answer when x is 0? X is 0, that means we need to have n elements which XORs to 0. So if n was even, then no issues, just take all the 1 plus 1 plus 1, answer would be n. But if n is odd, what we can do is, one possible way of doing it is like here in this example. You can see in the first test case that we analyzed. Okay, here x was 1. Let's say x is okay, this won't be an example of this case. Let's say n is 3. Let's say n is 3 and x is 0. So you need to have 3 numbers which XORs to 0 with minimum sum. So if you have 1 in every number, it would XOR to 1. So 2 of the numbers can have 1. So that XOR is 0. Now, for this number also, we need to set some bit. So we would have to set this second bit. Okay, now this would XOR to this. So you need to set one more bit in one of the numbers. So you would have to make it like this. So we can use 3 numbers like this, 1, 3 and 2. They would XOR to 0, but their sum would be 6. So you can have any of the 3 numbers. So this is the minimum we can have for n equal to 3. Minimum sum we can have is 6. Okay, this is the minimum way minimum sum through which we can make a XOR of C. Now for any greater n, what do we do? For n equal to 5, what do we do? Take these three numbers and then take 1 and 1. Okay, so for n equal to 3, answer is 6. For n equal to 5, for the three numbers it would be 6, then 1 and 1 would be 2, 8. For n equal to 5, answer would be 8. So basically answer is n plus 3. Okay, so because you are replacing one of the ones by 2, so a plus 1 here, and adding an extra 2 here, so plus 2 here. So an extra plus 3 you are adding to your final answer uh, from the number of remaining elements. So if x is 0, n is even, answer would be, if n is even, then answer would be n. If it is odd, answer would be n plus 3. Okay, that is done. Now when the number of set bits is 1, this is the final case remaining with us. When the number of set bits is 1, what do we do? If that set bit is, so if you have x equal to 1, that means that set bit is 1. So if like n is odd, then obviously we can have n ones. So n ones would XOR up to 1, no issues. Answer would be n only. But if the set bit is something different, and if the n is even, let's say even, so again, what you would have to do, in one of the numbers, you would have to set this second bit, and in the remaining final one left out number, you would have to set this bit. So always, whenever one extra one is coming, how do you settle that? In one of the one, set an extra second bit, and in the final number, set the second bit. So this way, you were supposing that all the extra elements are having 1, but here instead of 1, you are having 2. Here instead of 1, you are having an extra plus 2. So a plus 1 here, plus 1 here, an extra plus 3 would be added to your answer here also. So basically in both of these cases, when your n minus number of set bits was odd, okay, basically in this final else case, you would have to add an extra plus 3 to your answer. Okay, so if your answer would have been n, with the best case, add an extra plus 3, because you were not able to make it n. So one of the 1 got shifted to 2 and one of the 1 got shifted to 3. Okay, that way you are able to manage it. So in this extra else case, we would add a plus 3 to our answer, plus 3. That's what the whole solution is. I hope this last part was slightly confusing, but I hope you have got it. If you have any doubts, then maybe I can explain it more clearly. Yeah, I've messed it slightly, but just tell me once if this problem is clear or not. Okay, please summarize. So basically, to summarize up, what do we have? So this is the whole summary basically. If you have the number of, if n is less than equal to the number of set bits, your answer is simply x. Okay, you can always make, if the set bits is let's say 5 and n is 4 only, so you can always set 5 bits using 4 numbers with a sum of x only. You don't need to take any of the bits repeated in 2 of the numbers. So your final sum would be x, the minimum possible. If n is greater than the number of set bits, then first we would use n of the numbers to make x. Okay, so n numbers would make x, the remaining would be, sorry, set bits, SB numbers are going to make x. Okay, so if number of set bits was 5, the first 5 numbers are going to make x. What is the remaining numbers? Remaining is n minus SB. So if this remaining number is even, then take all the ones. So final answer is x plus the remaining numbers. So take all the 1 in all the remaining numbers, their XOR would be 0, final XOR would be x. If this remaining is odd, then again we have two cases. If the remaining is odd and number of set bits is more than 2, then in this we only need to add a plus 1. In just by adding a plus 1, we can make our final answer with the minimum sum, we can make it x. How? Instead of using SB numbers to make x, use SB minus 1 numbers to make x. Then remaining numbers would become even, and that way we can make x. So we, instead of 3 remaining elements, we would have 4 remaining elements. So one extra remaining element would come. So that's why we got a +1 here. Now, if the number of set bits is less than 2, that means uh, there is only one number or 0 numbers which are making x. So you cannot combine 2 of the numbers and increase your remaining numbers. Okay. So here how we were able to do it in +1, when we were able to increase the remaining numbers, this n minus sb, from odd to even. But in this final case, when number of set bits is either 0 or 1, then you cannot increase the remaining elements. So here we analyze this case, that how can we make. So the way was, whenever you want to make with odd numbers, you want to make a XOR of 0, then the best possible way is use these three numbers who would sum up to 6 and would make a XOR of 0. So instead of using 1, 1, 1 that would sum up to 3, you are making a sum of 6. So you are having an extra 3 in the sum. So that's why my final answer was +3 here in this case. Okay, so I hope this logic is clear. And now let's move on to the code. Okay, so the code would be simple. First of all, for one more slight edge case was there when n is 1, for the -1 case basically. When do we have a -1 case? -1 case was only possible when n is 1 and x is 0. Okay, minus for n equal to 1, x equal to 0. This is the only case for -1. For any other case, as we can see above, we were able to solve the problem. But for this case, like number of set bits was also 0 and n minus set bits was odd, but you cannot like do a +3 in the answer and make it, because whatever one value you take, that has to be greater than 0, and that won't XOR up to 0. So for this case, your answer is -1. For any other case, your answer is not -1. Okay. Now for n equal to 1, if x is greater than 0, that means that only element is x. Okay. That only element is x. So your final answer is going to be x. Okay. So I've solved the problem for n equal to 1 before only. If x is 0, answer is -1. Otherwise, answer is x. Okay. So n equal to 1 case is done. After that, we only have cases of n greater than 1. So for n greater than 1, for even case, problem is okay. For odd case, we have seen that we can do it like this and add a +3 to our answer. Okay, so all the cases can be solved. So using this if else condition that I have written here. So basically, calculate the number of set bits in x. Okay, so y is the number of set bits in x. If number of set bits is greater than n, your answer is x. Okay, or n is less than equal to number of set bits, your answer is x. Okay, you can have equality here or not. If even if you don't give an equal sign, then for n equal to number of set bits, in this else case, it would be like evaluated. This would be even, this would be 0. So your answer would be x only. Okay, so whether you write equal to here or not, it's okay. After that, once this case is done, for the else case, we need to check if n minus number of set bits is even or not. So n minus number of set bits, if that is odd, okay. So if that is even, my answer is x plus n minus y. X plus n minus y is my answer if it is even. Okay. So that's my answer. Now, if it is odd, for the odd case, in this value, we would either add +1 or +3 based on value of number of set bits. So if x is 0 or 1, that is the case, or even if you can write the number of y is less than equal to 1, both you can write. Okay. So okay, so let's move to problem C, which is Neo's escape. So Neo wants to escape from the matrix. In front of him are n buttons arranged in a row. Each button has a weight given by an integer. Okay, so there are n buttons and all of them has some weights. Neo is immobilized, but he can create and move clones. This means he can perform an unlimited number of actions of following two steps. Okay, create a clone in front of a specific button, move an existing clone one position to the left or right. So either he can create a clone in front of a button or move an already existing clone left or right. Now what happens whenever a clone gets created, immediately that particular button gets pressed. When you create a clone in front of a button, that particular button gets pressed. Or if you move a clone to the left or right, and that button was not pressed where the clone has now moved, then it would again get immediately pressed. If the button was already pressed, the clone does nothing and the button can only be pressed once. So this is what happens. Now, for Neo to escape, he needs to press all the buttons in such an order that the sequence of weights is non-increasing. Okay, so he need to press the buttons in this sequence so that you move in the sequence of decreasing weights. Basically, if you are pressing the n buttons in this order where the weights of the buttons are b1 to bn, then b1 should be greater than or equal to b2 likewise. So you need to press the buttons in decreasing order of weights. Your task is to determine the number of clones that Neo needs to create in order to press all the buttons in valid order. Okay, so you need to create minimum number of clones and press all the buttons in decreasing order of their weights. That's what the problem asks you. So let's look at this first test case to understand what we need to do. Okay, so let's say you have this n and this array. Okay, you need to press the button. So you can perform two actions. Either you in front of a button, you create a clone. And if you create a clone in front of the button, that button gets pressed. Okay, or what you can do is if there is already a clone present, then move that clone to the left or right. Let's say we move the clone to the left and now this clone gets shifted here. Now this button was not pressed already. Once this clone comes here, it presses the button. So this second button also gets pressed. Now if you move this clone here, now this button was already pressed, so it won't get pressed again. So it would not add any extra button press to your answer. Now when this clone moves here, okay, so then this button was not pressed, this would get pressed next. Okay, so if you create a clone here, move it here and move it here, what would happen? One would get pressed, then two would get pressed, then five would get pressed. Okay, in this way. Now what you need to do using these operations, you need to press all of these buttons in decreasing order of weight. So first 5, then 4, then 3, then 2, then 1. In this order you need to press. Okay, so how many minimum number of clones are needed you need to create? So for this case, in order to press 5, you would have to create a clone. There is no clone already existing. Then you need to press 4. Now 4 you cannot press using this clone, because if you move it to the left, this would get pressed before 4. So you need to press 4 immediately. So you would have to create a new clone to press 4. Then you need to press 3. So you can move this clone here and press it. You need to press 2. You can move this clone here and press it. You need to press 1. So maybe you can move this clone here and press it, or even that clone here. Anyways, so you can press this way. You can press 5, 4, 3, 2, 1 in order using just 2 clones. You just created 2 of the clones in total. So 2 is the minimum number of clones needed to create. So for first test case, your answer was 2. Okay. So this was the first test case. Let's look at one more test case to understand more clearly. So for this test case, what you can say is you need to first press the greatest number here is 10. So any one of the 10 you can press. Okay, because for equal numbers it doesn't matter which one comes first. So maybe you can press this 10 first, then this 10, this 10, or maybe you can press this, then this. So let's say if you want to press this 10, you create a clone here and press it, or you create a clone in front of it and press it. Then in order to press this 10, if you move this clone here, this 2 would get pressed. Okay, so you don't need to do that. You would have to create another clone here to press it. Now you can move this clone here and press this button. Okay, now you need to press a 9. So in order to press 9, you cannot move this clone because it would press 1 and 7 in its way. You need to press 9 next. So you would have to create one more clone in order to press it. Now you need to press 7. So you can move this clone here, press it, then move this clone here and then here. Move it here and press this 7. Then this 7 can be pressed while moving the clone here. Press this 7. After that, press a 2. 2 is the next greatest. So you can move this clone here and press 2. Same way you can move this clone here and press 1. And then you can move this clone here, then here, then here, and then here. So it got moved here to press this. So in total, you created 1, 2, and 3 clones. Move them here and here to press all the 10 buttons in decreasing order of sizes. So minimum number of clones needed was 3. So answer for this test case was 3. Okay, I hope the problem statement is clear. Now, just by analyzing this test case only, you would have realized that what we need to do. Like, it's kind of a greedy thing, but this is the best possible way to do it. So what we need to do here is, okay, so just start with the greatest value. Okay, now here we have multiple greatest values. So with which would we start first? So we don't know. So before solving this problem, let's try to solve when you have only unique values. Okay, so let's try to solve that, and then we would see how we can formulate it when we have multiple values. Because for multiple values, we don't know from where do we have to start. We may start from here, or we may start from here or here. Okay, so let's suppose instead of multiple values, we had only unique values. Okay, then how do we solve the problem? Then we'll move on how we can solve with multiple values also. So if you have only unique values, let's say you have 1, 7, 9, 10, 2, 5, something like that. Okay, all are unique values. Let's suppose we have this array. Then your order is fixed. First you would have to press this 10, then you would have to press this 9, then you would have to press this 7, then you would have to press then you would have to press this 5, then this 2, then this 1. You would have to press in this order only. Okay, now how do you solve the problem? So move in this order. First, when you are at 10, okay, just check. For the first value, obviously you would have to create a clone. But after that, when you move on to 9, just check whether just to the left or just to the right, is there some clone which you can move it here and press it. But if it is like for this 9 to the left also, to the right also, both of them are unpressed and there is no clones that are there, then obviously you cannot. If you bring some clone, let's say if you bring some clone to from the right, there some clone was there, if you bring it here, then these two on the way would get pressed. So the only way to press one particular button without creating another clone is if there is a some clone just to the left. Now just to the left, it may happen that this is already pressed and a clone is here, then you can move it here. Basically the button just to the left which is unpressed, or you can say that the button just, so one thing is the button just to the left, if let's suppose this is already pressed, which is unpressed, if that contains a clone or not. But that's not the actually the problem. The clone would be there. Clone would only be where the button is already pressed. So if the button just to the left is already pressed, then we can say that there would be a clone in this group, because you can see that whenever you create a clone, move it left, right, then one group of buttons get pressed. Okay, it would not happen that from one particular clone you press this and this button and this is unpressed. Always the buttons pressed by one particular clone would be consecutive. So you just need to check whether to its left, if the group of buttons to the left is already pressed, that means there is one clone there, through that you can press this button. And same way, if the buttons to the right is just to the right is already pressed, that means there is some group of buttons to the right through which you can press, which would have a clone through which you can press. So either if the button is just to the left is pressed or button just to the right is pressed, then you can press this button without creating another clone. But if the button, neither the button to the left nor the button to the right is already pressed, both of them are unpressed, then you would say that you would have to create a clone, a new clone to press this button. That's the condition. I hope just by looking and analyzing then. So let's do a dry run on this test case. So for 10, you have to create a clone. For 9, you saw that just to its right there is a 10 which is already pressed. So you would say that this gets already pressed. Okay, and in this group there would be one clone which is going to press it. Okay, obviously this clone would move here to press it, but we don't need to track what the position of the clone is. We only need to track whether the button is pressed or not. So if there is a group of consecutive buttons that is pressed, that means there would be a clone in that group. Okay, so we only need to track whether the button is pressed. Next, let's move to 7. Just to the left button is unpressed, but just to the right button is pressed. So can say that we can press this button without needing an extra clone. Okay, now let's move to 5. So for 5, just to the right there is no button. Just to the left this button is unpressed. So for 5 there is no button to the left of right which is pressed. So in order to press this 5 we would have to create another clone. So initially my number of clones was 1. When we created another clone, we updated our answer to 2. Okay. Next we move on to 2. 2 we would say that to the left also, right also, both of them. Both from anywhere we can press this 2. Both the buttons are pressed. So we can say that this button gets pressed either from this one or from this one. Okay. And then we move to 1. Just to the right button is already pressed. So this also gets pressed without increasing my answer. So my final answer is going to be just 2. So this way you can solve the problem. So what you need to do is just maintain a check vector where check I denotes whether the button is whether check I is 1, it means pressed. If it is 0, it means not pressed. Okay, so just maintain a check vector. Initially all the check I would be 0. Initially all are unpressed. Start with the greatest value. Okay, move in the order of decreasing order of AI. Move in decreasing order of AI, and then whenever you have a I, check if the button just to the left, which is check I minus 1. Either that button is pressed or button to just to the right, which is check I plus 1. If that is pressed. If any one of them is pressed, no issues. You can just press the ith button. You can mark it 1 that yes, this button is pressed without needing to increase my answer. Else, you would have to increase your answer. You would create a new clone and then you would mark this button as checked. Okay, so that's the only thing you need to move in decreasing order of AI. And for the index I, you need to analyze for the index I, not the value AI. Okay, value AI would matter for sorting and index would matter for checking. So if I minus 1 or I minus plus, if any one of them is pressed, just press it. Otherwise, increment your answer and then press it. Okay, this way answer would be your final answer. So this is how we solve the problem for all the unique values when there are unique values in the array. What if there are equal values? Now, how do we decide whether we start with this particular 10 or this 10 or this? So I would say just start with any one of them. Let's say you start with any one of them. So you start with this, you need to press this button, create a clone here, press it. Okay, then you move to this, you need to press this to the left, right, both of them are unpressed. So create another clone and press it. So your answer becomes 2. Now in order to press this 10, this clone is there, so you can press it. Okay, to the left it is already pressed, so just press it. For 9, to the left, right, both of them are unpressed, so create another clone and then press it. Then for 7, there are 3 7. Let's consider this 7 first. To the right it is already pressed, so you don't need to create another clone here. Press it. To the left already pressed, so press it. Don't need to create another clone. For 7 it is already pressed, press it. No need to create another clone. For 2 already pressed, press it. For 1 already pressed, already pressed. Okay, so with 3, again if you applied the same algorithm in this duplicate values also, you got 3 only, which was the correct answer for this test case. Okay, but what if you have something like this? Let's say you have 10, 9, 9 and 6, 5, 10, something like this. Okay, let's try to apply the same algorithm here. So 10 is the greatest. You check it. Create a clone here. Answer is 1. Now to the left there is a 9. Okay, sorry. For the next greatest value is 9. Let's say you start with this. So if you pick up this 9 first, you would have to create a clone here and mark it. Since to the left also, right also, both of them were unpressed. So you would have to create another new clone here in order to press it. You would have to increment your answer to 2. And then when you come to this 9, the left one was already checked. So you marked it, you pressed it without needing to create another clone. But if you see to press these 3 buttons, you created 2 clones. What you could have done is, instead of considering this 9 first, after pressing this button, you consider this 9 for next, move this clone here and press this button. Then you consider this 9, move this clone here and press this button. So just with one clone only, you could have pressed all these 3 buttons in order 10, 9, 9. There was no issue. But since there were duplicate values and you considered this 9 first, you incremented your answer, which was wrong. So this algorithm doesn't apply with duplicate values. So what do you need to, how do you manage this? When is my answer failing? My answer is failing when you have like these 2 consecutive duplicate values where this 9 was close to a pressed button, this 9 was not. So by considering the 9 close to a press button first, you were able to press both of the 9s. Okay. Anyways, if you have 2 values which are same and they are consecutive, so you can consider these 2 9 as a single 9 and then say, if from the right you can press this 9, then just press both of the 9s, and or from the left you can press this 9, then also you can press both of the 9s. So whenever you have the same values, consecutive same values, instead of considering 2 of the 9s, let's create another vector where you have a single 9 instead of 2 9s. Then it would not cause a problem. But if you have 2 10s at different position, this is not causing a problem. So like here also, when you had 2 of the 7s at different position, that was not causing problem. 2 10s at different positions were not causing problem. 2 10s at same position, they may have caused a problem, but since it was initial value, it didn't cause a problem. But here it caused a problem. So basically what is causing a problem in my algorithm is when you have the same value in consecutive times. So if you consider, instead of these 2 9s, if you consider a single 9 and then apply the algorithm, it would work fine. Because for the like duplicate values which are at different position, there is some different value in between them, then you would have to cross this 5 in order to press them. So if it is smaller value, then you obviously cannot press both of the 10s with the same you cannot press both of the 10s with the same clone, because 5 would be pressed in the middle. And if there is some greater value, let's say 12, then obviously if this 12 was pressed, then from this 10 would also be pressed, this 10 would also be pressed. So when the same value are at different position, there is some different value in between them, that is not causing a problem in our algorithm. But when same values are at same position, that is causing. So in order to solve this problem, from the array A, make a new array, let's say A dash, which where we would see that when we have different value, we won't have any consecutive same values. So create a new array B with removing all those consecutive same values, taking a unique, taking them only one time. Okay, so 6, then there were 2 9s, take it only one time. Then take a 10, then take a 5, then take a 10, then take a. So create a new array A dash, and in this array A dash, perform the same algorithm as described above. Start with the greatest value, create a check vector, check I, initialize it with 0. Start with the greatest value, mark your check as 1 and answer plus plus. Then if to the left or right, this algorithm works. If to the left or right one of the button is pressed, just press it without needing to increase the answer. If both of them are unpressed, increase your answer and then press it. So apply that algorithm in this new array. That would be your answer. Okay, I hope it is completely clear to you. Let's move on to the code. Okay, so here we take the input. I'm creating this new array B from the initial array A. So how do I create the new array B? For every value I would check if the previous value is unequal, then I'll push it into B. If the previous value is equal, then I would not push it. Okay, so L stores the previous value. It's initially -1, so first value obviously it would get pushed. If the current value is not equal to the previous value, I push back, otherwise I don't, and L is AI. So for the next value, this would be my previous value. Okay, so this way I create the array B, and now the size, whatever is the size of array B, is the new size of the array. Now, in order to move in sorted order of AI, I create another vector vec, which is a vector of pair where I store bi comma ai. So when I would sort vec, it would get sorted in the order of bi. So based on the value of the array, it would get sorted, and I would have the index stored in the pair with me. So when I move in this sorted order, now when I move from I equal to 0 to n in vec, then vec I dot second would give me the indexes in sorted order of vec I dot first, which is bi. So I'll get indexes in sorted order of bi. So j is the index of the greatest element, vec 0 dot second, then vec 1 dot second would be second greatest, vec 2 dot second would be third greatest, like this. Okay, so when I'm moving in this order, now what I have to do here, I have to just check if I minus 1 is already checked or I plus 1 is already checked. Now this I minus 1 or j here, j minus 1, this may become negative, so I'll have to check whether j is greater than 0. Okay, so for j equal to 0, there is nothing to the left. So I need to check if there is something to the left. So if there is something to the left and that something to the left is already pressed, or if there is something to the right and that something to the right is already pressed, in these two cases, I'll mark check of j as 1, check of j as 1, and I put a continue so that I go to the else case only if these two conditions, both of them are unsatisfied. So if both these two conditions are unsatisfied, I'm going to go to the continue value. I'll go to this block where what I do is answer plus plus and check I equal to 1. So then I'll do check j equal to 1 and increment my answer. Okay, so after this I print my answer. I hope this problem is clear. If you analyze the time complexity, this input part is taking order of n time, this part is taking order of n time, this part is taking order of n time, this sorting is taking order of n log n time. Here we have simple if else conditions, which is O of 1, so overall order of n time. So my overall time complexity would be order of n log n for the sorting part, and my space complexity would be order of, we have used vectors of size n, this would also be at max b of size n, vec of size n, check of size n. So all the vectors are of size n, so space complexity is n. Okay, so I hope if this problem is clear, we can move on to the next problem. So the next we have problem D, needle in a Numstack. So this is an interactive problem. So what the problem states is you found the numbers k and n in the attic, but lost two arrays a and b. You remember that the sum of the size of the array is n, and both the arrays are at least of size k. The array consists only of numbers from 1 to k. If you take any k consecutive elements from A, they will be different. Also, if you take k consecutive elements from B, they will be different. Okay, so this condition, if you analyze this condition, the array A only has elements from 1 to k, and if you take any k consecutive elements, all of them would be unique. So for any k consecutive elements, all the k elements from 1 to k would exist. That's what it states, and both the arrays are at least of size k. Now, fortunately, a kind spirit has settled concurrented them into array C, that is, elements of array A were first written in array C followed by elements of B. So array C is the concatenation of array A and array B. First all the elements of array A in order, then all the elements of array B. Okay, so now you can ask the spirit up to 250 questions. Each question contains the index I. In response, you would receive the ith element of the, so you can ask 250 queries. In every query you can get the value of the ith index of array C, okay, which is the concatenation of array A and B. The ith index of array C you can get, that would be returned as the answer to your query. You need to find the lengths of array A and B or report that it is impossible to determine them uniquely. So you are given n and k are given to you as input. So the sum of the sizes of array A and B is n. You need to uniquely determine what is the size of A and what is the size of B. and you know this k for these conditions. Okay, so you need to determine this in 250 queries. That's what the problem is. Constraints are n is up till 1 is 6, k is up till 50. There are 300 test cases and the sum of n is not limited. So you cannot solve the problem in order of n, because 1 is 6 into 300 would be 3, 8 may give you TLE. So you need to consider that thing. Okay, now let's try to find out how do we solve the problem. So let's look at one of the example. Okay, or from here, let's say. So you have two arrays. One is array A. Okay. Let's say basically you are given two arrays, array A of some size, array B of some size, and you know the sum of the sizes of array A and array B, this is equal to n, that you are given. This n is given to you, and you are also given, okay, n comma k is given as input. You are also given k, which means that the size of A and B, both of them are at least k. This is the first condition. Okay, what all conditions do we have? Both of them are at least k. The array consists only of numbers from 1 to k. So AI, BI, all of them would be in the range from 1 to k only. Okay. And then if you take any k consecutive elements from array A, they will be different. Same for array B. So for array A, whenever you take, let's say, k consecutive elements, then for these k consecutive elements, all the values would be different. So k1, so from all the values from 1 to k would occur here one time. So with this, what can we say? Let's say k is equal to 3. So array A can be something like 3, 1, 2. For the first three values, you would have everything from 1 to 3. Okay. And then what would come with this fourth index? Now it should satisfy that these three values are all unique. So you cannot put a 1 or 2 here, because then these three would not be all unique. So you would have to put up a 3 here. Same, what would come here? These three values need to be unique. So you cannot put 2 or 3. You would have to put 1 here. What would come here? These three values have to be unique. You would not pick 3 or 1. You would have to put 2. So once you determine the first k values of the array A, all the other values of the array are automatically determined with these given conditions. So you would have a permutation of size k initially, and then that permutation would just keep on repeating. 3, 1, 2, 3, 1, 2, 3, 1, 2. That way it would keep on repeating. So that's what your array A is. That way it would keep on repeating. Same for array B, it would also be of the same pattern. Now your final, your array C is the concatenation of array A plus array B. So there would be, now for array A and B, they may have different permutations for the pattern. Array may have 3, 1, 2, 3, 1, 2. Array B maybe it have 1, 2, 3, 1, 2, 3, something like that. So maybe when you concatenate it, let's say array B is of size 6 only. Let's say array A is of size 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So let's say n is 17, k is 3, and you have something like this. So your array C would be 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, and then 1, 2, 3, 1, 2, 3, 1, 2. Okay. So that's how your array C would be. Now, you don't know this arrays A, array B, array C. Okay, you don't know the sizes of the array, but you have 250 queries to determine them. In every query, you put an index, you would get CI. What is the value of that? Now, let's look at the constraints. K is up till 50 only. So, in order to determine the pattern of array A, if you check the first k values of the array, you will get the complete array A, what would be there in array A. Or if you same way, if you get any 3 elements from array B, you would get the complete array B. You can do it from the last also. If you take the last 3 elements, then same thing would be repeated. You can say that Your array B is 3 to 1, 3 to 1, 3 to 1 from the last. Okay. So now in this array C, you know, this array C would be A0, A1, A2 up till whatever is the last value of A, then B0, B1 up till whatever is the last index of B. And you know, at least K values are there in array A, at least K values are there in array B. So now in between, you don't know where it is changing, at what point you are changing from array A to array B. But you know for sure the first K elements are from array A, the last K elements are from array A, and K is less than equal to 50 only. So even if K is 50, in 50 queries on the first 50 elements, you can get the complete pattern for array A. In 50 queries on the last 50 elements of array B, you can get the pattern for array B. So in at max 100 queries, you would get the whole pattern of both the array A and B. So you can utilize 100 queries in this on the first K values and the last K values. So put a query on the first K values and the last K values, you would get the pattern for array A and array B. Now you just need to determine where this transition from array A to array B is happening. So after these 100 queries, whenever you are at some index I, let's suppose, can you determine what the value of Ci should be? So if this Ci ith index is belonging to array A, and we know the first 50 values of array A, you can easily determine what would be the value at ith index of array A. Okay, you can say the value at ith index of array C. So if it is coming from array A, then it would be CMF A of AI modulo K. You can say if you do a mod K, then like from 0 to 4, if you are taking 0 based indexing, then 0 to K minus 1, the same thing gets repeated. So when you do I mod K, okay, for any index I, it is same as A of I mod K. So Ci would be either A I mod K, or it would be, if ith index is falling in array B, then it would be, let's suppose whatever, if you are determining the last K values of array B, then for any ith index you can determine the distance from the last value. If that distance modulo K would give you the which value is coming at ith index. Okay, so this also you can determine. It would be n minus I would be the distance from the last. Okay, if it is 0 based indexing, it would be n minus 1 minus I. Okay, n minus 1 minus I. Okay, this module. Okay, I'm considering reverse indexing. For array B, I'm considering reverse indexing instead of straight indexing. This is B0, this is B1, this is, okay, likewise I'm moving. Okay, so in array C, if I do a query on the n minus 1th element, I get B0, then I get B1. So this way, for any ith index, it would be the distance from the n minus 1th modulo K, B of that. Okay, so this way my Ci would be either this or this. Okay, so for any ith index, we know there is two possibilities for that value. Now, based on whether the actual value at that index is this or this, we can determine whether that index belongs to array A or array B. Now, there are n elements in this array C. You need to find a partitioning point. So you can see that you can apply a binary search till some value x you would belong to array A. After that, rest of n minus x values would belong to array B. So you can move like in a binary search, and for any index I, you would do a query in that index I, and if that Ci is equal to this value, then you would say it belongs to array A. Search for this partitioning point to the right, and if that value is equal to this, then you would say it belongs to array B. Search to the left. So this way, like in binary search, for n equal to 1 is 6 also, at max it would take 20 iterations to determine it. So in 100 plus 20, 120 queries only, you are done. You have to limit of 250 queries. So that's more than enough. Okay, so that is fine. But there is one small issue with it. What if AI and
these two values that you are considering? What if they both are equal and that is equal to Ci? Then how would you determine whether it is coming from array A or array B? It may happen that here if you move this, so for any index I, you move k steps back, whatever you get, you move k steps forward, whatever you get, these two values are the same. Okay, for a random permutation in array A and array B, both the values are at some particular index are same. So there you cannot determine whether it belongs to array A or array B. So basically then how would you change your low and high in your binary search? So what I would say in order to solve this issue is, for any index I in the binary search, first check with what should be the value of that index through A and through B. If both of them are unequal, apply the query and you can easily determine. But if these two values are equal, then applying a query here makes no sense because you already know the value. So don't waste your query here. But say that yes, at this in, so let's say you have some low here currently, your high is currently here, your mid is somewhere here in this ith index. You don't know, like both the values from A and B are the same, so you cannot determine here. So if you can't change the value of low and high now, how would your binary search work? So what you can do is move to the left of this, move to I minus 1. Okay, whatever mid is there, move to mid minus 1. Maybe at that value, the values coming from here and here are different. So check if for I minus 1, these two values are different. Then apply a, basically for that value, just apply a query and check if that belongs to array A. So for, if let's say for I minus 1, this value belongs to array A, then you can definitely say like you can move your low pointer, but for this index I, you cannot say. Now it may happen that now you know for sure this I minus 1 at index belongs to array A. So your partitioning would come something to the right. But if let's suppose your final partitioning comes here only, if your final partitioning comes here only, and in this ith index it is undeterminable whether it belongs to array A or array B, then in that case either your final partitioning should be this or this. So you don't know for sure whether the size of array is up till here or up till here. So this would be the case of -1 where you cannot determine. So what I'm saying is, for I minus 1, you know for sure it belongs to array A. For I plus 1, you know for sure it belongs to array B. But for ith index, you don't know whether it belongs to array A or B. Then either your partitioning would be here or here. So you don't know for sure what is the size of array A. You can include this value in array A also, B also. Then your answer would be -1. So you need to also consider that thing. So basically what we would do in the binary search is, we would search for such values which are confirmed in array A. So we would search for my binary search would search for I such that Ci belongs to array A. Search for such an index I which belongs to array A, and so if you are searching like that, then in this array C, for all the indexes, you would get a true result for some of the values until where you have array C. After that you would get false results. That after that you have array B's. So you need to find the maximum index which is confirm a position of array A. Search for the maximum I which belongs to array A. That's what you need to search in binary search. And if your mid is undeterminable value, move to I mid -1. If that is also undeterminable, move to mid -2. If that is also undeterminable, move to mid -3. So if you move up till from mid to mid -k, after that if you have moved to the left k times and all the k values are undeterminable, that means you have an array where the initial permutation of both array A and B are the same, and the partitioning point is also such that it's like that. So you just cannot determine till where you have array A or array B. You can take any of the partitioning. So that would be a -1 case. So for any mid, at max you would have to move 50 steps back. At max you would have to move 50 steps back to determine if even after moving 50 step backs, if all the values are undeterminable, that means your answer is undeterminable. But if moving until 50 steps you get any value which is determinable, apply a query there in that value, and if that belongs to A, add that in your answer. And then if let's say I-1 was also undeterminable, I minus 2 undeterminable, I minus 3 was determinable, it belongs to A, then what we can say about comment about the index I? If this belongs to array A, then all these indexes may belong to either array A or array B. You don't know. So you can say that what value for sure belongs to array B would be to the right. These are undeterminable values. So you can put your low here, put your low at I plus 1. So you can put your low at I plus 1. Even though you queried for I minus 3, still you would put your low at I plus 1. Because you know for these values, these are undeterminable values. So no need to search in this range. Search only for the determinable range. Put your low as mid plus 1. And if that belongs to array A, put that in your answer. If that belongs to array B, don't put it in the answer. And put your high as I minus 4. You may put your I as high as I minus 4, or even if you put it as I minus 1, it's okay. It would be managed. So basically you would apply a query only once for every binary search iteration, but that query would be applied only after searching for an index where you can where these two values are unequal. So searching for an index would take order of k time at max, and the binary search would take log n time. So overall time complexity would be order of log n into k. This would be the time the binary search may take at max. Okay, because k time extra is taken in searching for a determinable range, and the number of queries would be 100 queries at the start, or 2k queries at the start, 2k queries at the start, and log n queries there. So at max this many queries, which is less than equal to 250. At max this time complexity k into log n into even t is fine. This is 50, this t is 300, log n would be something like 20. So this time complexity is also fine. Okay, so I hope the logic is clear to you. One last final thing that you would have to check, whatever answer you get from the binary search, whatever I you get from the binary search, okay, where you say that this I is the maximum I such that I belongs to the array A, then you would say that I plus 1 should belong to array B. So you will have to once check if this I plus 1 is undeterminable. If this I plus 1 is undeterminable, where these two values are equal, then your answer would become -1. That here we can do a partition, but we can do a partition here also. So there are multiple answers existing, your answer would be -1. Okay. So whatever final answer you get from the binary search, check for I plus 1 value if it is determinable. If it is determinable, it would belong to array B only, because if it was belonging to array A, you would get it from binary search only. Okay, so I hope now the problem is clear to you. It was an iterative binary search problem. So let's move on to the code. How do you write the code for it? Let's look at the implementation. So I move to all, initially I'll do the 2k queries for the first n values to get the values of my array A, last n value, first k values to get the value of array A, last k values to get the value of array B. So you do a query. I'm taking 0 based indexing in my array A and B, but in the query I have to take 1 based indexing. So I query for I plus 1 on this. Okay, and then whatever value I get, I put in my array A. So I get the array A of size k, and then for any other index through this array A, I can determine the value of that index by taking mod k, A of I mod k. Okay, so I create this array. So for the first I values, for the starting I values, I get the array A, and from the last I values, so n minus I, n minus 1, n minus 2, for these indexes, I would get array B, Bi equal to 1 in reverse order. So at index n, I would have B0. At index n minus 1, I would have B1, like this. Okay. So now I got my array A and B, the first k elements of array A and the last k elements of array B I have got. After that, if the size n is 2k only, that means size is kk. Obviously, you can just return like this one. You don't need to check anything extra. There is nothing in the middle. Both the array has to be at least of size k, array B has to be of at least size k. And if the sum is 2k only, there is no extra elements. So both the answer is k comma k. Return out. Now if size is more than 2k, apply a binary search. You would search in between. Okay. Ignore the first k value. They are already in array. Ignore the last k value. Search from index k to n minus k minus 1. In this range, you would search from index k to n minus k minus 1. And if you don't find any basically solvable index in that range, then your answer should be k minus 1. So k minus 1 is the last index where at least you would have array. The first k indexes has to be array. So you would suppose that this is your answer, and then you would check for I plus 1. If that is determinable, then that would be array B. Okay. Otherwise, minus 1 would be your answer. Okay. So you initialize your answer with k minus 1. Okay. And now in the binary search, you take the mid, you initialize I with minus 1, and then you iterate through all the k values from mid to mid minus k. So initially it would be mid minus j. From you run a loop from j equal to 0 to k minus 1. So initially you check for mid minus 0, which is mid. Then for j equal to 1, it would be mid minus 1, mid minus 2, mid minus 3. So for all those values, you check a of ii mod k. You check these two values. This is your v1, this is your v2. Whether these two values are equal or not. You get these two values. If they are unequal, that means that index is solvable. You can do a query to determine whether it belongs to array A or not. So you take that index in your index I and break out. You found a solvable index. If not, then you continue your loop. Even after running k times, you don't get a solvable index. That means I would remain minus 1. You break out. That, yeah, my answer is unsolvable. Okay, if you find a solvable index, then what you do? You query for that index. Okay, whatever result you get, if that result is equal to array A, that means that results belong to array A, then your answer would be I. Yes, I belongs to array A and low is equal to mid plus 1, search for even higher value. Otherwise, that belongs to array B, high would be mid minus 1, search for lower value. Okay, so this way I perform the binary search and then just check for answer plus 1, v1, v2. If the values are equal for answer plus 1, then you print minus 1. Otherwise, print your answer. Okay, this I less than n minus k was for this edge case where you have I is the answer, and then I plus 1 is basically the k values of b only. So if I is equal to n minus k, okay, n minus k, then if you are checking for I plus 1 and they are same from both the side, but still this n minus k plus 1 index would belong to B for sure, because the last k indexes would belong to B. At least B is at least of size k. So if you have array A of size n minus k and array B of size k, and you know this belongs to array A, but this I plus 1 index is undeterminable, and you say your answer is minus 1, then that is wrong. Because if this is determinable as A and this is undeterminable, but still, if it is belonging to the last k elements, it is determinable that it belongs to array B only. So for that one possible edge case, I am writing this condition. If I is equal to n minus k, then don't print minus 1, print your answer. But if I is less than n minus k and the answer plus 1 at that value is undeterminable, then print a minus 1. Otherwise, S1 is answer plus 1, whatever index, maximum index of array is there, plus 1 is the size of array A, and size of array B is n minus s. That's your answer. Okay, I hope it is clear to you. Here my time complexity was, this loop is running k times, this loop is running k times. Okay, so k times loop and k queries also. Okay, this is order of 1. This binary search is running at max log n times, and inside that you have an order of k loop. So this is overall order of k into log n. Okay, and these are order of 1. So time complexity is order of k plus k into log n. So overall it's k into log n. Okay, and number of queries at max would be, here you have 2k queries here and only one query in every binary search, so at max 20 log k queries. So it would be 2k plus log n queries. Okay, so 2k is, it's 2 into 50 plus 20 approx, which is in at max 120 queries only you are solving the problem. Okay, here in time complexity you would have t test cases also multiplied with it. Okay. This is fine, t is 300 into 50 into 20. Space complexity would also be, for every test case, order of k space you are using to store the arrays. So order of k. Okay, so I hope this problem is clear to you. Thank you so much for tuning in. I hope you liked the PCD. Goodbye.